Welcome everyone to this next lesson on energy transformations. Today's lesson we're going to be looking at the roller coaster. So as before, we will start off with basics about the roller coaster and then go through a couple of problems from this year's workbook as well as the test from earlier on. So as with the pendulum, in a roller coaster, the total energy of the system is always going to remain constant. Now, it's always going to be a matter of how you calculate that total energy and then apply it to whatever question is actually being asked. Now, the total energy is always going to be a combination of the kinetic energy and the gravitational potential energy at any one point. And you can calculate the total energy of the system easily from two key points in the roller coaster. First of all is this point A here, which is your highest point where your height is at a maximum. At this point, the gravitational potential energy is 100% of the total energy with no kinetic energy at all. So if you want to calculate the total energy, you calculate the GPE based on the height value that you'll be provided with. So the height will usually be somewhere here in your question, and you'll be able to use that to calculate your total energy for the first part of the question. Now for the second way to do this, you can actually calculate the energy from the bottom of a hill where the height is equal to 0. Be aware that it is only a scenario where the height is equal to 0, and I'll explain that in a moment. But at the bottom of a hill, all the energy is kinetic, so it's 100% kinetic energy with 0% as GPE. So you can use your kinetic energy formula based on the velocity, so you'll be given a velocity value at this point to calculate your total energy. Now the reason I specify this only when the height is equal to 0, there may be scenarios where you'll have to calculate energy based on a dip that is not actually right at the bottom. It is not height equals 0, there is in fact a height above the ground. Be aware of that. If it's not height equals 0, don't use it to calculate the total energy, but chances are you will in fact be given a height and get your total energy from GPE. So here's our question from the 2015 workbook, page 17, question 15. The question states, if a roller coaster starts from rest at point A, which is up the top, what is the speed at point C if the track is frictionless? Now you're going to have a statement like this, which basically means that no energy is lost in the system, but it won't change how you calculate anything. So what you have here is at point A, the height is equal to 12 meters high. And as you can see, it is at the top of a hill. And it's also the highest point in this roller coaster. So we can calculate the total energy using the GPE formula, which is equal to mgh. M is a value we don't have quite yet. Don't worry about that, we can eliminate it later. Our G value is always 10, and our height value is equal to 12 meters. So that gives us an answer for the GPE of 120 times M, which is the total energy of our system. With that number in hand, we can now go ahead and try and calculate our energy at point C. Now at point C, the total energy is going to be a combination of the GPE and the kinetic energy at point C. So we plug in our generic formulas for GPE and kinetic energy, which is mgh and also mv squared on 2. We also know that these two things combined must be, of course, equal to the total energy of the system, which we just calculated. That energy will not change. Now each of these features of the formula each contain mass. So we could do just a quick elimination of mass. We can also input the numbers we have. We know that G is always equal to 10. Now the height at point C is equal to 4 meters, so we can put that value in as well. So we end up with a formula that looks like 10 times 4 plus v squared on 2 is equal to 120. We rearrange that to get v squared on 2 equals 80. 120 was from the energy before. The 40 is equal to this 10 times 4 that's gone to the other side of the formula. Keep on rearranging. V squared is equal to 160, and the V value for the velocity is equal to 12.6 meters per second. So here's another kind of problem which we've gone over a couple of times from the 2015 test. The reason I go through this is basically because it's one of those rare occasions where the cart is located at the very bottom of the ramp, which means that the height is equal to 0, plus we will be given a velocity value. If you see a velocity value up first, chances are you're going to need to use the kinetic energy formula to calculate the total energy of the system. Now in this scenario, a roller coaster car is moving at 20 meters per second along a straight horizontal track. Predicted speed after climbing the 15-meter hill shown in the figure. Neglect the effects of friction. Again, standard statement to say that no energy is gained or lost in the system. And I'm going to mark our scenario point with a star. So of course our first thing is to measure the total energy of the system. Now in this case, at the bottom of the ramp, because our height is equal to 0, all of our energy is kinetic energy at that point. Our kinetic energy is equal to mv squared on 2. We don't have a value for m, but as before, we're going to leave it as it is. Our value for velocity is 20 meters per second. Now, as they are all our standard units, we can leave that value as it is and put 20 squared into the formula, format that out, and that will give us a value for the kinetic energy of 20 times m, and that is the total energy in this roller coaster system. Now, at the point where the star is, which is where we want to find our answer, the height is equal to 15 meters. Now, the total energy at that one point is equal, of course, to the kinetic energy plus the gravitational potential. So we do the same thing as before. We put in our generic formula for GPE plus our generic formula for KE. Now, again, we have calculated the total energy from before, so that it ends up being those two things have to equal 200 times m. As before as well, we can now eliminate m from this formula, and we're going to rearrange it to get GH plus v squared on 2 is equal to 200. Our G value, as always, is 10. Our height at this point is 15 meters. So plugging in our values and rearranging, we get 10 times 15 plus v squared on 2 gives you 200. V squared on 2 is going to equal 50, which is 200 minus 150. V squared is going to be equal to 100, and our velocity is going to be equal to 10 meters per second. This is actually a multiple choice questions, which is why it comes out as such a nice, neat answer. So thanks everyone for watching. Hopefully this video was helpful. Questions and comments in the section below, and good luck everyone with your exams.